What are we doing today? Today we're going to try and solve ARCAGI. I mean, solve is a big word. We're going to start working towards testing ARC-AGI. We will use pure reinforcement learning only. So, yeah. So, let's start. Effectively, let's go to show you what the tasks are. You have this huge JSON which is not very clear, but what the way that you do it is that you start here. Let's solve the daily puzzle and then start working towards the proper. Oh, the examples don't work. Okay, what if I do it from Chromium? Hopefully I don't have any tabs open, weird tabs. Nope, still does not work. Anyway, here, yeah, okay, let's solve this. Let's solve an evaluation. A training set v1, v2, because we're going for AGI-2. Okay, so we have this input, and this is the output, and then we're given this input, and we have to guess the output. So it immediately we can see that this color, light blue, is on the top, and then pink, and then pink, and then yellow, and then on the bottom it's mirrored. So this is here and this is here, and yeah, effectively it's just repeating pattern of the normal thing, and then mirrored, and then the normal thing again, and it should be the same here. Yep, it's exactly the same here. So wait, yeah. So the ARCAGI needs us to guess the correct configuration also of the output grid, and then we need to do the colors. So it should be here, here, and here. Okay, let's do the red. Is it this red? Oh, this should be the. Oh yeah, this is the red. Okay, so it should be this. Oh, here. Yep. Okay, and then we have the oranges. Okay. And then we have the blues. And this is the solution to the puzzle, effectively. Yes, correct. Try the next puzzle. We will not try the correct puzzle, in fact. But this just to show you how ARC-AGI works. Okay, so how do we do this with reinforcement learning? Because you can't zero-shot the solution. You can't just be given, let's go to the next. You can't just be given these 3, 4, 5 examples and then immediately see this and say, ah yes, the actual pattern is, and you just plaster the pattern, right? Because even LLMs or reasoning models, or however you want to call them, have issues, mostly with the grid size, with some examples, but like these, it's just weird for a reinforcement learning agent to have an input and just output the entire thing. Because it doesn't really work that way to reinforcement learning. So in my approach, what I've thought about is that its test is an episode, a full episode, and the way that this works is that you are given these states at every step, included all of the examples and the test, and you paint once at a time. So how you paint once at a time, you will see everything because we'll write everything in code. And the way that you paint is that you have 3 different states of move, effectively. The first state is going to be the vertical movement, and then the horizontal movement, and then the coloring. And so it will automatically configure the output grid based on the examples here. So it should be 9 by 9, and then based on this, I don't know, I'm not going to try and figure out the pattern. It should go here, let's say at a random let's say here, it picks, the first thing that picks is this, so it has the entire column selected, and then it picks a row, so it has a unique block in the grid, and then it chooses between these values in order to give the color that it picks effectively. And it does that for many different spots, and effectively once it feels it is done, or until the time has passed, the time steps have passed, that we give it probably the x by x, or we could just do it 30 by 30 because the max size is 30 by 30. But yeah, once it does that, then it receives the final score, and at each step there is going to be a small reward. So if we go back to 9 by 9, every time it goes here, if it is correct but it's not the correct color, then it might take a small penalty. If it goes to a place where it should not have a color, it should not have a penalty. And if it, yeah, so I don't know if it should make sense to train it on this only, or if it should be like given the test also. We will figure it out as we go, I guess. I haven't really thought about this. I've been thinking, it's in the back of my head for a couple of days, week, I think 2 weeks maybe. But I saw this and I was thinking that's a perfect use case for the electors, the package that I'm maintaining. And so yeah, this is effectively the goal. So if we go forward with this, we can go, we're already at the Likio. Yep, I bumped the version because I added the, I mean, you'll also see if you see me stumbling a bit, it's because I am very much, I woke up about 2 hours ago, and the coffee is over in the house, so I made some tea, but the tea does not contain enough caffeine, so I'm struggling a tiny bit. Yeah, anyway, so we have Likio, and so yeah, the change that I made since last time, of course, is that in card games I added blackjack fully, so I just passed blackjack, because if you see on the repo, I made different branches, and then I input it to master, so it's a bit cleaner. I try to behave in a proper formal way in how I do the Git stuff, even if it is mostly probably not going to be seen by other people that much. But anyway, we are here. We are here. So what we want to do is that we are going to go up a level and make a course called make the ARC-AGI, the ARC-AGI, that's init. Okay, and put it here, and this should go here. Okay, and we are going to be importing data. Oh yeah, I also pushed the MMLunar thing that I did in the previous stream, and the reason why I did that is yeah, this is another thing also. Oh, I haven't pushed it. It's okay. So the reason that I pushed it and not streamed it again is because effectively I've already done it, and it would be like boring for me to be here and just repeat what I have said already. But yeah, so we can go here, ARCAGI, Helix, nope, it should be, or yeah, let me ARCAGI exams. Okay, so Likio, as I've said already, is a Lyceum, which is a high school in Greek, and so this is an exam. These are the games that the agents play to learn play games. Like they play blackjack on the between classes, or they might do courses that I have planned. MML Junior is one of the courses, another one is playing Hangman, so board games where they learn to use the entirety of the token, the vocabulary space, as the action space in order to produce guest tokens in a block of text, which could also be afterwards used as an auto-regressive in nature. But anyway, these are going to be the exams. This is a graduation exam for the agent in this thing. So helix ARC-AGI-2. So I'm going to need to import probably numpy and lectors import agent, if I remember my own package. Wait, have I added them? Lectors, no, I didn't. I hadn't, more correctly, and it has, yeah. Okay, so I'm going to be referencing a bit stuff from my laptop, not anything else other than MML Junior, effectively. Because it's going to be pretty similar in terms of how it's going to look at things. Do I have? I might just push actually the ML Junior, so I can take it out and you can also take it out. So it should be done. I mean, it needs a bit of a cleanup. Yeah, it definitely needs a lot of cleanup because I haven't transferred the next step function. But in any case, whatever. Okay, so we're not going to. I'm not going to push that yet. Helix arc. Okay, so we have numpy. We care about the bees in my window. The mint are producing flowers, and the basil also, so it's driving the bees to come enter my house. So we're importing random because we want to shuffle, and we also want the Hugging Face datasets. Okay, so we have this, and obviously we want from base import base cores, from core import the description and action. So what we're going to be doing is let me from electors import agent, because this is my own module at the bottom, although it could be here, because I like to have the files, the custom files in at the bottom themselves. 1 second. Okay, so so class ARCAGI, it should inherit base course, and it is RLM for the ARC-AGI competition. And yeah, so let's go def init. So self num questions. No, we're going for the entire data set. As it is an episode, we're going with seed, which is going to be int, and we're going to set it to 1, and we could do test or val. I'm looking at the MML Junior code that I have, and honestly it's going to look pretty similar-ish in terms of, but for now let's only have the seed and we'll add it if we need it. So super ARC-AGI, I don't know how to pronounce it. I like ARCAGI. ARC-AGI is probably the correct way, or ARC-AGI is probably correct, that's the way, but I don't really care about that. So the init function, and I've been thinking, like, you know, I'm not a really big fan of Python's syntax for these kinds of things. I've been thinking of using NIM to make DSL, a domain-specific language for machine learning. So I might work on that at a later point once because now I need obviously to have more friction with everything that's going on, so I can do it easier and understand stuff. But anyway, so we're going to say that the self dataset is load dataset, and the dataset is going to be here. Use this dataset. Yeah, so this. I much prefer this over the. I prefer single quotes in Python. In NIM, obviously it's different. The double quotes are for strings, single quotes are for characters. But here, I think it makes it a bit cleaner in essence. So, okay, we have that, and then it's be the train. So I will figure it out. So yeah, okay. So we have the dataset. This should be it. And now we need the reset. We also need the step. Yeah, self action of action, and it should return a tuple of. If I remember correctly, it should be a tuple of state description and comma int, because we're doing the, I mean, yeah, at every step it's +1, I guess. The int, and then the bool, and then bool now truncated actually makes sense, and then dict str any. Yeah, and since this goes beyond the style guide, let me make it like so. Okay, so what the reset should do is that it should reset, it should go back to the beginning, so it should be yeah, okay, so the exam set is equal to self dataset, and it should be the train set dot shuffle with seed. Oh, sorry. It should be with this seed. Yeah. Okay. And yeah, we don't have. We're doing the training here. I mean, I could do the. I could change it so it loads the elector, and then it could be okay, train or eval str, and it should be or it could be eval is eval bool false, and here if not is eval train else exam set test, right? Yep. Dot shuffle need seed. Okay, so this is training. This is shuffling the dataset, and then it's returning the exam set at every reset, and then the agent can train on the set. Okay, and now during the step it should be, I mean, and what do we return? We return we return again, no, we don't return a tuple, we return state description. So this should be yeah, okay, so we need to make a generate description thing. State description. Okay, and so we need here generate state description, or just for ease of writing, we can just generate description, because the state description is the old description. Self exam set, yeah, and should it be exam set or exam set 0? Should it be the 0th item? No, because we have the few shots and the question, right? So we need to have we need to split it up here. Because, yeah, okay. So first of all, let's do the step. So we're given an action. Yes. Okay. Generate description. Yeah. Okay. So we need also IDX, and we have to do it in a very specific way, to be honest. Because every step needs to be broken down into 3. So we need to have a way to do. We need to choose column, row, and color. Okay, so it's going to be 0. So this is the internal state tracker, step tracker, or whatever that we are probably going to need. And it should be the state. Okay, so we have this. We have the state description. We have the reset, which generates. We have the exam set, and then based on that, we can go and say that the yeah, okay, and it should be the questions per tier. No. So okay, let us, rather than this, let's do the we could, instead of having an episode being 1, no, it makes much more sense to have it being, okay, so so what I want to do is I want to check this thing here, right? So it's an input, so this an array of JSON, so it's an input, it goes, can I have it in a human friendly readable way? Okay, so this is the input. It has this, and then this, and then it's another JSON object. Okay, so we need to flatten this effectively, or do we not need to flatten this? It could be that you have to guess all 5 per episode, so each episode could be a test, and it tries to guess okay, so there is no way to be able to solve the question. What we could do is just go through the questions and ignore the inputs, the few shots, but at the same time the few shots are extra training data that we can try and solve, and so we could just molds everything together in a sense. This could be, but at the same time you could give these as a solution. Okay, so I remember what my plan was. So we have here, we pass the exam set, so we have the exam set here, And so what we can say is the fact that we split it up. So we have the few shots, comma, the question equals with exam set. This should work, right? Because I mean, let's spend the extra 5 minutes to find out. Yep, okay. Python, yeah, okay. And now let's go from datasets, import, load dataset. Oh, come on. Do I not have it? Oh, I don't have it. Okay, well, yep, okay, done. Datasets, import, load dataset. Yeah, okay, and dataset, dataset, ARC-AGI community / ARC-AGI-2 to me. Oh, it's probably like this. Okay, so let me fix this here because yeah. Okay, so we have everything. So if we say dataset, it's the train dataset, so we want dataset train, as we already said, because we're not in eval, and it has the features, few shots, and question. So can I do few shots and yeah, okay, perfect. So this is just a list of lists of JSON objects. So if I do few shots questions equals with dataset train, does this work? Too many values. Okay, so it should be, I mean, if we go and say few shots it should be again the whole thing. Yeah, okay, perfect. What is okay, dataset is still this. Yes, train tours. This is JSON, so we don't have access to it effectively. Yeah, what if I do then? Okay, here got features. Yeah, okay, and here 0, nothing, because it does not have this. So if I go shots, okay, so nothing. Effectively, this is the types, so it doesn't have the information. So we go and say yep, here equals with, so dataset train is the exam set, so it's exam set few shots and questions exam set questions question wait, few shots hot question. Okay, yeah, question. So let me also do question and q and print q. Yeah, okay, so we have the data set, we're happy. So this shuffled and then passed generate. So we have that okay, so we can say description if you are taking in an exam, your task is to okay, so this should be also the instead of IDX it should be action class. It should be to pick the column. Okay, yeah, I'm solving it as we go, right? And it should also be passed to the generate here. Oh yeah, we also need the self IDX then. So this goes immediately we go up by 1. So we start at 0 and we are given the we just want the exam set. We want it to be like this because it's, you know, no, we can't have it like this because we need to go to the next one. Oh fuck, it's going to be self. Yeah, we're not going to be safe. Yeah, okay, so I don't really need to pass it like this because we're just making it have side effects. Okay, I don't know if it's faster or not to not have side effects, honestly. So we have this. Exam set, and then we can, okay, so we have this, okay, clear few shots 0 input output, yeah, okay, perfect. perfect. Okay, so we can go here and say that this is off. Okay, and the length of few shots, honestly, yeah, okay, then few shots 1000, perfect. So it's always 1000, and yeah. So now what we want to do, half an hour has passed, it doesn't feel like that. Your task is to guess the correct pattern based on the examples. Examples are, and now we're going to have the few shots. The question, I named it Q, right? The Q is this, and so we don't need the output. We want it to figure the output, and we want to compare to the output. So we're going to have the, so what if can I do Q0, and then how do I do it? 0 again, it should be, yeah, and then input. This is so ugly. Because it's always on, no, it might be more than 1. Huh? It's going to be 1 to 2, right? That's what it said on the site. It's going to, wait, it is going to be 1 to 2. No, some private, yeah, format. typically 1 to 3. Oh my, no, okay, yes, this is the test. Okay, no, we want the input and output things. They have information about that? I don't see it. If there is, if you know anybody, correct, incorrect. Yeah, the process. Yeah, okay. Funny how they do not say anything about reinforcement learning, even though reinforcement learning is probably like reinforcement learning solved chess and solved Go and solved like very difficult tasks, and I don't know, they treat it as if it's not existent or anything. It's a bit weird. Yeah, we will train it and then go to Kaggle. I will train it on my GPU. I don't really, no, on my CPU. Maybe I'll try and fix my drivers for the GPU. The problem with my GPU is I'm running Nobara, Fedora spin-off essentially. Wait, let me. So I'm running Nobara, as you can see, and because of this, the problem is that it is a gaming distro, and it is therefore not really meant for reinforcement learning. I mean, Ubuntu 22.04 is what most people use for reinforcement, for machine learning on Linux. So it's not really, ideal to have a gaming distro with the most up-to-date drivers from AMD, because then my GPU sort of breaks with Torch and their own updates. And so, yeah. Anyway, I don't really see them having, and it doesn't really matter. Sorry. Yep, and yeah. So the input for the question is, and we said question 0 input. So we only care about the input. It should not know the output. And because we wanted to guess the output, but we want to have for us the information on the input. Yeah. And also, because we're going to have column row color, you are currently picking self-action class. Okay, so another thing that I was thinking is that in theory you need to guess the column. I mean, you can hard code it, but that feels a bit like cheating. So, but at the same time, if it works on this, then I might look into expanding it to the actual like extra to do the extra mile and not be like cheating. Because if this works, it's already extremely impressive. If it gets, I mean, for me, if it gets I don't know, 3%, so no, that's 30 of them. I mean, I think that it can get like 10%, honestly. I don't know about ARC-AGI-2, but at least the ARC-AGI-1, it seems to me very reasonable to expect a good performance from reinforcement learning agent, because it learns. It's a game. I don't know. It's much different from LLMs, because LLMs are frozen at inference. This one is not frozen at inference. It will learn on the dataset. I mean, it's going to fine-tune itself to the dataset, but that's the RL experience in a sense. Yeah, so I think I should start at the same time developing the main so we have, yeah, we have, I need to remove some of these, but anyway, so we have all right, yeah, blackjack here. Okay, so let's, I mean, I will use this because it has everything. What does it have everything? Does it have gymnasium? Yeah, I don't want it to be local path though. I mean, want this to be local, but these should not be local. Did I use UV here? I do use UV. Okay. But yeah, it's no update. That was the mistake last time. Okay, so it should be like this: void 3 install, no root. Don't care about this being installed. We do care about the swap. Hopefully this works. But while we're waiting for the installation, yep, okay, so man, the weather is not kind these days. Yeah, okay, so here let me make another example. ARCAGI. It should be from Liquio import dot exams. I like this. How did I use this for blackjack? From Liquio.games. Yeah. Okay. Helix ARCAGI. From Liquio import ARC-AGI. Yeah. Move ARCAGI ARCAGI.py. Okay, and it should also be from import agent. Yep. And yeah, so we need these two. I will reference the example. So right now we're going to build the training loop because we need to sort of figure out how it's going to do that in order to do the environment. Blackjack, yes, let's go, money. So we need, why do I need the OS? We'll find out what we need as we need it. From Takadem, import Takadem, very important. Okay, so this we're not going to use. We're going to use the ML flow thing that I've set up. So we have the env equals to with ARC-AGI and the action space. Oh, I need more caffeine in my body. Available actions. So we need to do this. So yeah, so what we need is here to run to have the need state. We need to have dot available actions. No, we need to have that as a function. So here, let me self pass for now, although it should just be how did I do it? Okay, we're playing around, we're fooling around. Blackjack. But for blackjack we have that the action, yeah. Oh, I haven't implemented this. Oh my god. It's so... oh no, I have. Why the... Okay, so let's steal this. Oh, it's going to be so annoying. I need to do it 30. It's 30 actions. Okay, so wait. Peak call 1 peaks the I mean it's going to be very annoying. Peak oh peak item 1 label call row color. Should it be 0? No, it should be 0 to 29 or to, yeah. And now fuck me, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, like, okay, so this should be, is it? So the final row is 79 and this is 50. 79, so it's 30. Yeah, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. Yeah, okay, so this is the oh god, this is so boring. I mean, it's boring, but you have to do it, right? As one of my favorite YouTubers says, it puts hair on your chest. Ah, fuck. Yeah, 14, 15, 16, 17, 18, 19, and these should all be 20. Wait, yeah, these 20 here, so 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Which one did I miss? What the fuck? Oh, 20 here. Fuck. Yeah, okay. Okay. So this is done. These are all the available actions. Me. Okay, so the action list is this huge, all available, all available actions. Pick item 1 to 30. How do I mean, this is a doc string, so this for me, so let's do it. Pick this and then it is 1 to 30, or I will do, yeah. So it's not for me necessarily, it's for anybody that might want to work on this, but it is for me because probably I'm going to be the only person working on this. So yeah, we have all of them. Oh, the first description, second. This is torture. Should I do? Should I? Because we're going. I mean, this is not for me even. Like doing this. Fuck. yeah. What the fuck? What am I doing? Yeah, this is not for me. This is for like the MCP server that is being built. This is not even for the for the reinforcement learning stuff. So let's get rid of that, and then let's go here and let's do it a bit more. Yeah. So the description, you have the, yeah, okay, because even in the MCP server you're going to give both the information of what the action is and what the description is. And for this we have these. You have the currently picking, the column, row or color. I mean, I could make that a class, an enum, but it doesn't really matter, does it? Okay, so we have the ADX, we have the return state description option. So this is what type is the, wait, let me open a third terminal. Nobody saw that coming. What type is the project Likio poetry run Python port load set? It should be here, right? So we have the data set. Oh no, we need more up. Yep, we need here. No, not the U. Yeah, okay, so we need the data set is type this, so the data set of train is okay. And so if we do the type, the dataset is class datasets are its dataset. Okay. Do I need all of this? Type. Port, yeah. It's IDX, yeah, but what I need is the type. How do I want to be proper about this, please. No, they don't have that. Wait, Troy. Huh? The hell. Huh. Yeah, no. Okay. It's not here. So we're not going to have that. Anyway, so yeah, so I don't need the exam set here. Yeah, and do I have that? I'm going to I hate how it looks, honestly. Okay, so we want to take the action. Okay. So there is a reward every 3 steps. How am I going to do this? This approach won't work. You will not win 500k and Zach will not hire you for 100 million bonuses. I don't do this for the money, my guy. I mean, the point is literally to see if it works. I mean, I'm not going to work for Zach anyway. I mean, I'm not even in America. Thank God I'm not in America. And I'm not planning to move there just so I can become like, I don't know. I'm very critical of the way the American big tech complex has been handling these things. But anyway, I'm trying to see if the approach works. Obviously, I get that it's a joke to say the thing about winning 500k. Is that 500k the prize even? You know, it will be an upheaval if it does even 1%. Everybody will like, oh wow, reinforcement learning works, and then people will give me money for free. No, but yeah, this is just for fun. In any case, this is DPL v3 code, right? Oh, I haven't showed that yet, but like, yeah, the entire thing is DPL v3. So I have licenses here, DPL v3, and this, which forces anybody to be to use as DPL, and if you use any part of this code for training, it also has to be DPL. So I'm not in this for the money. This is very free source, free software, free and open source software stuff. So as I said, I just want a 1%. I'm not going for like 100% solve or whatever. I just want to see if this is a valid way. So anyway, to go back to the thing, what I'm trying to do is that I'm trying to figure out the reward function for this, because we have 3 different steps, right? We have the step of picking the column, we have the step of picking the row, and then we have the step of picking the color. So we could have my first intuition was to have the action space be the total amount, which is 30 by 10, which would make it 30 by 30 is 900, would be a space of 9,000. And I'm not a fan of having that. My action space is not blackjack actions. What do you mean? I made another environment, which is the blackjack, for another game. I made reinforcement learning. Effectively, it returns the available actions for hit or stand. This is a multi thing. This is for reinforcement learning, but also it will have an MCP server, so that it can also be used by LLMs in training or whatever, in order to maybe help them with decision making, even though they don't really do that. So the description is this. Here's the available actions. I don't know why you say that it has to do with blackjack, where you saw that, to be honest, but yeah, probably because of this. So I should close this because I have taken already what I wanted from this. It's to not confuse you. And let me close the buffer here also, so we only have the ARC-AGI. So yeah, I'm trying to transfer the other work that I have done onto this effectively, just so I can work my way through easily. So I'm building the environment. As I'm building the environment, I have the example of like working on this, which worked surprisingly well, and now I just want to transfer the thing. I'm lacking caffeine, so I need to reference something effectively, and as I'm going through it, I figure out what I'm missing in the environment. I'm going back to the environment. That's the strategy today. So we have the action space, which is this 30 by, so yeah, because if we go, so I haven't come up with evaluator yet. What I'm working at is probably going to be, so I'm not going to one shot, or I'm not going to zero shot, or whatever. I'm going to go to, okay, let me, so again, how I want to solve how I want to go about this problem. So let's go to a training set v1, whatever. I did that. Yeah, so let's go to this one. So this one has this as the input, and this is the output. This is the input, this is the output. So the idea for this one is that if you have an enclosed space, you add the color yellow to it, right? And so what I want, because we have the solution in the JSON, what I want to do is that I want, first of all, I will not try to guess the grid. I'm not going to guess the size of the grid, because it doesn't really make sense in the way that I'm approaching this to do that. I mean, I can do it at a later time, but for now I just want the bare minimum functionality, and then I might start adding stuff. And the way that this works is that it's going to, now you have this output, right? And it's completely empty, it's all zeros. And so the way that it will work is that I want the agent to, the agent has three phases. It has here the three action classes, which is going to be column, row, and color. And so it's going to start picking, and it will pick an output. It will pick a column for the output, let's say, and now it has selected the entire column here. And then the next step of the 3-step per pixel kind of thing step comes, which it picks the row, so it locks in on, let's say, this, and then it paints green, right? And this, I think it's comparable to this, probably. I mean, I let's do it here so it's easier for me to say. And so then it can pick between, let's say that it has selected this tile here, and then it will pick between 0 and 9 the color, and we'll pick this one. And if this color, if this value here corresponds correctly, it will get a result of 1. If it gets the correct spot, I could do it in a total of, you get 0.25 for guessing the correct column, a valid column. You can get 0.25 for guessing a valid row, so locking in a correct pixel, and then 0.5 reward for the correct color. And so it could start learn to fill the space in this way, compared to the output, which the output is not known, right? Because I'm only feeding it the input of the question. I'm feeding it the examples. I'm saying these are the examples. Yeah, okay. So I'm feeding the examples, and I'm feeding it the input of the question, which is the, oh, sorry, yeah, is this thing here, and then based on this, it has to guess. That's the whole thing. Yeah, and I'm going to use the outputs dimensions in the dataset, in the Hugging Face dataset here, to just give it the X by X of the thing, of the grid. That's the idea. Yeah, exactly. So reward after each pixel. So if the pixel is correct, it's going to get a positive reward. And if it's going to be a miss, it's either going to be 0 or a slightly negative reward for the reinforcement learning agent. I'm using proximal pulse optimization, by the way. But yeah, effectively, each step is actually 3 steps. So I'm tripling the amount of time, because I could have it just be a 900%, a 9,000 action space, where it just has each action is the column, row, color coordination. But that seems silly. Like, I don't want such a huge action space. I want a much smaller action space so that it can learn to optimize. And because I'm giving it like this, because I'm giving it like this, it has the information of what action class is being passed through. And the way that I'm working is that I have a BERT encoder embed everything, and then pass through PPO, which PPO is equipped with transformers, and that's the idea effectively, and I'm working for it right now. So we want to go to the step, and okay, let's not go here, let's go here. So we have the available actions, and let's seed everything. np random seed 1 torch manual seed 1 and random.seed 1. So these are done. So we don't care about this because I've set up ML flow. So we're going to say the ARC-AGI, yeah, and its param. So now you're going to see the silliness of what I have done. This effectively, these are the hyperparameters that I need to have for the for the agent, the Alexa as I call them, the agents that I have created, the natural language reinforcement learning agents. So you have the epochs, you have the bat size, you have the policy clip, the value clip, whether to normalize advantage or not, the entropy, ARC-AGI. The reason everything here is in arrays is because I was trying multiple things out, and I had I think it's here. No, it's not here. There was in grid search. I have a grid search, the function that did I create it here or did I import it? I don't remember. It was a month ago plus. So what it did was it created just grids of different hyperparameters combinations. So yeah, so I will go through a bit about the network structure. So you have the epochs, you have the bat size, policy clip, value clip, the advantage normalization, whether it be true or false, the entropy, the actor reads. Okay, so this is the actor reads is the first non-standard thing for the for proximal pulse optimization. I read in a paper on Archive, which it's not anything special on Archive. People treat Archive now as if it's the nature, but it was a suggestion that it was beneficial for continuous learning. So for very long data sets at steps over the million line, it helped preserve plasticity and it prevented catastrophic collapse. You have clip grad norm for the exploding gradients. Now the hyperparameters are passed as a dict. You have the optimizer, which is the how you call them, the argument for the optimizer. We're using Adam, so we have two betas. The 0.9, the default one is this. I went for this for the same reason of this. The reads, the existence of reads, I read in a paper. So source, I read in a paper. Maybe I can find the paper at some point. But yeah. Do I have it here in the papers? Solving vehicle overcoming, I think it's this one, or otherwise it's this one. Yeah, it should be this. Yeah, so it's an open review, it's anonymous author. You can find the author from the metadata, if I remember correctly. This has been worked on, but yeah, this is my source for the choices. They used L2 and non-standard stationary Adam, so non-standard beta 2, and they figured out that it's better. So I'm using that because in my thesis I was struggling a lot. This one is suggesting a different optimizer, UPGD, which seems very good. I've implemented that, but I'm using Adam because I want to know that everything just works. There is, I don't know about okay, so no optimizer will work for ARC-AGI except slow as fuck evolutionary optimizers. I sort of agree. I mean, I don't agree that the optimizer needs to be evolutionary specifically. For me, it feels more like it just needs to be able to learn from the data. Like my issue with LLMs and like reasoning models and all of the current hype and like I don't know, like everything in general is the idea of you train it and then it's frozen and then it no longer trains. There is the paper that came out a couple of days ago about the auto updating, auto regressive model LLMs. I don't really know about it. I haven't read the paper, obviously, yet. But at the same time, it feels to me like it's supervised learning complemented by reinforcement learning seems to me inherently bad, worse than the pure reinforcement learning for things, because obviously you can train a reinforcement learning agent to play chess or Go much better than you can fine-tune O4 or I don't know, whatever, ChatGPT 5 reasoning super special model or whatever. So it seems to me that reinforcement learning for specific tasks can reach superhuman games. So if I feel like if I can phrase this environment as a game correctly, as a reinforcement learning environment, it might have a chance to work better than what has been tried already, because I've seen that it has. For ARC-AGI, I think I've seen people try CNNs. I mean, I'm on the Discord to talk about things, but yeah, it doesn't seem. I don't think it needs to be an evolutionary optimizer. It's probably Adam is not going to work, which is why at some point I'm going to move to the UPGD. I have it on GitHub actually. A fork of their implementation, if I remember correctly. Let me check. No, the repositories. Yeah, I don't use GitHub. I'm on Codeberg, and I self-host my own Git forge for this. So here it is. Their optimizer. It's effectively this. I'm not going to explain it now. I need the mathematics make sense, but the implementation is just a big wall of like stuff. So I just copy and paste this obviously and work with that because it's already a ready-made optimizer. But it seems to be a bit more stable for catastrophic forgetting and loss of plasticity, which is what you want. You want for ARC-AGI. I feel like you want it to hold for longer effectively. So yeah, let's get back to this. I was explaining this. So these are the H params. You have the optimizer here. You have transformer layers and then linear layers. And because of the difference in dimensions between a transformer and a linear layer, you have an attention layer as a gate, which reduces dimensionality. And so you have the transformer and then the gate, and then that brings it down to a linear set of layers, and the input is obviously the embedded dimension, so it's 768. And so now then we reduce gracefully because I found that works better. And we have the same for the critic, but bigger, because critic, an actor can be smaller without that much loss. Like it seems that in proximal pulse optimization, the critic is more necessary. Like a good criticism is better than good actions in order to learn. And so let's do the magic phrase of device CPU if torch CUDA is available, else CPU. Okay, and with MLflow, I don't care about that now. We have an elector. Let me elector equals agent. Elector equals with agent. It's very obvious. Let me remove that. Agent with the output deems equals with it should be how did I say that? Action space and available actions. Len of the action space for the actor, verbose equals true, so we can have some logging stuff. Device equals device, and then we pass the H params. Okay. Why did it say that? Did I mess something up in the electors? Anyway, so continuing, We have the for loop. I mean, okay, we have the extra data that we have. Number of episodes. So the number of episodes is the length of the environment, which is 1000. So we can have the I mean, okay, so the rollout is going to be 1024 for beginning. Total step for logging or when to learn is going to be this. We don't care about entropy near 0 for now. And we have the reward array. I mean, okay, let's chill for now, because the window we don't need to care that. Numlearn, yeah, we need the numlearn for the MLflow stuff. But so for now we only care about the for loop. Int academ range. Okay, so the number of episodes is going to be given to us by the environment here. Okay, so we have that but let's say now for episodes is going to be 1000, because that's how many games there are. So yeah, so num, actually, I mean, yeah, I'm seeing some tiny flaws in my design now, not in the results, but like the way that I'm implementing this versus how I'm implementing the actual class. So the state is going to be n.reset. Done. We don't have done, we have terminated, truncated, so we're not going to have that. Why do I have it like this? Okay. Many questions about how I used to do this. So I had while not done. While, okay, so it makes sense. False, not done. Truncated, terminated, or truncated, or not. So this is going to be false. Can I put these truncated and terminated? Well, truncated or terminated, because those both start as true, as false. So while it is, wait, no, while not. Yeah, so these are both going to be false, so it's going to return false. So not is going to return true. Okay. Oh yeah, you're not crazy. I'm crazy. I have an AMD GPU. Thank you very much for that. I have CPU. Yeah. You're completely correct. I have an AMD GPU, so I don't use CUDA that often. Yeah, thank you. Well, not truncated or terminated. It should be the loop, so it should be the action. So total step plus equals 1, and then we have the action IDX, because we're turning the action in the state as an action object with the action and the description, and we want the IDX. The probes, the val is equal to elector.choose action state description. So this is going to be the state description. You don't know that because you so I return a state description from the generated description. Wait, have I? Yeah, this is wrong. This needs to be an arrow. So the state description is an object. So in base, no, in core, it has effectively, the state description is just a natural language description of the state. So it just has its state description with description. So yeah, so it's the state description here, and we have that, and then we take the action and the probability and value. We have the new state. So the next, so this is the updated by a single pixel state that we have. Reward done, truncated, terminated, info is going to be end step given the action space action IDX, because the action space is going to be available actions, which is just the list here. So it picks the IDX 5, it just picks the action, pick item like 5. Yep. And then it goes to where were we? Yeah. So we have the new state, the reward truncated. We need to store this information. Store, and so we store the state description, so the natural language description, the action IDX, the probes, the reward truncated, terminated, and that's all. We don't have the info. The probabilities, the values, the reward, truncated, terminated, the state, yeah, okay. And now score reward. I mean, this is just a bit silly. And then the rollout, the training, total step rollout is equal to 0 and num. Wait, well, oh yeah, this was for a single thing. Yeah, I don't need this. Because I found out when I was training for blackjack, I don't know how to explain it. I mean, I guess I can explain it. So it trained for 124 episodes. It gathered data because the rollout is 124, right? It did this, and then it trained once. I wanted to see if it was true. Like, it trained once, and then it was just fully optimized. Essentially, it just needed one time to play, and then it could learn how to play blackjack, which is insane to me. And I don't know how it optimized so quickly. Probably because I have the layers were too many layers, so the network was too big, and it like immediately fell into a local optimum, and then more trainings did not help it optimize. That's my idea, but like, yeah, it's pretty pretty well to me. So I wanted to test it out, and it actually worked. Anyway, so num learn plus equals 1. So the reason why I do total step plus 1 here is that it doesn't train on the 0th step without any data, with only the first state effectively. So we do that, and then losses or learn. So the learn function returns the losses, and then we log them. We do the ML flow stuff, and yeah, we can I just return this so I can log them. Everything is done internally inside of the agent class. So this is the entire loop. So we need to build based on this loop then. So let me close this so I can do this and then do this, and so we can compare and see and build. So the IDX is plus equals to 1 if yeah, so we are given the action, yeah, so we're given the action. Okay, so we have the action list here. Should it be self? Why am I oh, oops. Oh no, helix ARC-AGI, yeah. I'm a bit slow, as I said already. I'm lacking in caffeine. So yeah, I might stop soon-ish. I want to just do finalize the environment, and then I will just end the stream probably, because I'm can't think properly, and I've been streaming for 1.5 hours almost, which is weird. I'm happy that I can pull through like these sessions, just talking and thinking. It's very good for my self-esteem regarding my ability to focus. So yeah, we have the steps. So what we want to do, I need to figure this out actually. So we'll have the reset. So the reset state takes us back to the beginning, so, and takes us to be the first action in class. So we want to go to the column. We pick the column. So the agent returns a value, an index, and so it should. I'm probably not going to work on this today. I need to think a bit about this, but it could be, or maybe I do it later, at a later time. Calc reward self action, and then yeah, I'm using GhostTTY. I find it very good. I was at Alacrity, but my problem, I really like Alacrity. I also tried Kitty. I don't like Kitty that much. I don't like the modular aspect that you have to like play with the kittens. The naming also is horrible. But Alacrity, I found this font, which is Maple Mono, which I really like the ligatures of, but Alacrity does not support ligatures because of their obsession with it needs to be very fast modality. GhostTTY is extremely fast in my opinion, and it has ligatures, so it has everything I want. My only problem with GhostTTY is that you need to run a command when you SSH into servers. So when I SSH into my Raspberry Pi or to my VPS where I have my websites and like the GitForge, it doesn't really allow me to clear, for example, without having to run a command. I think the command is like iter something. It's in the documentation. TY SSH. So if I do this, it will be like immediately, yeah, the termifo stuff. You have to run you have to run this command, the infocomp blah blah blah, which, you know, it's a one-time thing per machine, but if you have to handle multiple machines, or if you're like setting up machines all the time, GhostTTY is not that good in that sense. You know, it is what it is. If more people use it, the Xterm GhostTTY will be more supported, I guess. But yeah, so the reason I'm using it mostly is the ligature support at a decently quick terminal. I mean, yeah, I also use Wayland, I don't know, but yeah, the GhostTTY is very annoying, but it's a one-time thing. There was also a way to do it in your SSH config. I did that, it doesn't really work, but again, you have to do it once per each server. But you know, it is what it is. I'm not going to. I mean, people have complained. The developers is adamant about, yeah, this is imperative to the terminal. I need it to not work over SSH by default, because he needed to do extra stuff, which I don't really use the extra stuff, to be honest. So maybe I should, but yeah, it's a really good terminal. So as I was saying, I need to do the calc reward here, which I'm not going to do now. I want to have first of all the step. So we have the few shots. Let me yank this and take this for here. So what we want to do, we have the few shots. I'm going to probably play around with I could do it. I mean, I could do the few shots to be in the reset, because it just loads because it just picks the self IDX. I mean, yeah, whatever. Oh yeah, here it should not be question 0, it should be it should be yeah. So we'll have the few shots, self exam. So we have the question 0. We're going to be at 0, so we want to take that. So we're giving this from the, I'm going to make it so that it's going to be given to us. And if column in self.action class, okay, and if row in self.action class, and if color or color, I don't care, I'm neither British nor American, action class. Yeah, so here, or this could be in the reward thing. I mean, okay, it's a bit weird, so let's do it slowly, because I'm stupid and slowly is better. So the first thing, okay, so ARC-AGI has 10 possible options for colors. So if immediately, if the action, if action IDX is bigger than 10 for the color, reward equals -100. So we want to really punish it for when it is in color picking mode, when it picks something that's not a color, because if it's an empty, you could do it be repeating, so 0 to 9 being the colors, and then 10 to 19 being the colors, and then 20 to 29 being the colors. But I don't like that. So let's say that if it's in color, if you see the color token, it should be immediately punished for picking something that is not between 0 and 9, actually. Or yeah, let's do it. I prefer this because then I can do this, and I really like the ligature. That's the only way reason. So else we have the color, and we add the color to the row. Oh, we need to keep track of the row and column picked before. So let us go to okay, so at the end of the column picking, we have that the self.action class is going to be the row, and here we're going to be self.action class is going to be the color. Yeah, because we set it here, and then at the end the self.action class is going to be the column again. So it's going to rotate between the three, and it will fill up the entire space, or it will just play the game effectively. Because it can play infinitely, we need to set up a horizon also, but I'm going to do that. I mean, we can do the we could use the IDX thing for it, but it's wrong, so it should be an internally tracking thing, so it should be another one. Step to horizon is equal to, let's say, 30 by 30. We could do it 900, and if for smaller ones it could just play more, or it could be based on the size of the output, which probably I'm going to do that. So the step we have here, okay, because here we're going to start with a 0 0. So I need to remove that from return. I need to put this like the function is equal to that, and instead of returning the state description here, we're going to return so it should return the few thoughts and the questions, and the description can be made at the reset actually, so I don't really need this. I can just use this and put it here. Ideally I want to stream the project. I want to work on the project while streaming. Otherwise, we have our own. I have my own self-hosted repo here, which is here on Likio. But at the same time, I have decided that I'm going to to bite the bullet. I don't know how to say it. So I have the, let me go, yeah, here. I have set up a mirror here. This is a read-only mirror. You can also, obviously, you can like make issues, you can do stuff, but the development is going to be on my repo and this self-only mirror, so you can see the development as it goes, honestly. But yeah, my plan, my wishful thinking is that I'm going to do everything on stream in terms of development until it's at a state, and then I'm going to try and start running it when it will not make much sense to stream, because like you're just, at that point I'm just seeing a bar load very slowly because I'm probably going to do it on CPU even. So yeah, I don't know if I'm going to do that. I mean, mostly after the environment is complete, mostly it's just playing around and fine-tuning. Oh, I had grid here. Yeah, that's why the autocorrect was like that. Yeah, I'm just going to be playing this. This loop is not going to change. It's mostly just these hyperparameters. I might update the put updates on the Discord for ARC-AGI also. I don't know, but yeah, the plan is to just be very open about this. Again, it's a GPL project. It's GPL v3. It's free software. Because I do that because I think like it should be like, I don't like open source as much as I like free software, because open source is a bit restrictive to the end user. Like the fact that the Intel management engine in the CPU runs a proprietary operating system a layer lower than whatever the operating system on the computer is, right? And that is open source MIT. It doesn't feel very like good. So I do everything free. I try to do everything in a free software way, for the freedom of the user, not the freedom of the developer. The developer is secondary. I am a developer and I don't care about my freedom. I care about the freedom of the user more. I mean, ideologically, whatever you want to say. But yeah, probably the things after is going to be here. I might go and implement the UPGD optimizer also. But yeah. GPL is copyleft, yeah, the GNU public license. It is the first copyleft license, effectively, GPL v3. And because because the Electors library itself is GPL, I mean, people don't have to keep up with, don't have to do that. There is no way for me to enforce it, right? But because the Electors library is GPL, it's not LGPL, it's GPL. This has to be GPL also. It needs to be GPL because of the requirements of the library that I use. And so I try to force the developers to work with free software, which might drive developers away, because obviously people don't think there is money in free software, and honestly there might not be. But I like to think that this is much better as a free software than just open source taken by a company, no credit given, and then just modified in a proprietary way for evil stuff, which is like how companies do things nowadays. Not evil stuff, like no company is evil. People don't do evil things to do evil things. Like nobody's cartoonishly evil, but people justify actions that the majority of people consider wrong, and they justify them with, I have to do this to make money or to advance society. Like the road to hell is paved in good intention is like a saying. I don't know. People do evil stuff because they think that the ends justify the means, in a sense, and I don't like that. I don't want to give them the option in a sense. But yeah, enough with the ideological mumbo jumbo. So let's go to here. We're working on this thing. So I don't really need the generate description. If I remember correctly, I have it in my. It should be here. Yeah. Okay. Oh no, I wanted these to be in this here thing. So we have the few shots which we're going to self. Do I do self and move forward? No, because I don't. Yes, I do want them to be in to be globally in the. Wait, but if they're not. Yeah, I might go and clean this thing also, because there is no point in me going to. Oh, this is actually internal variable on stream and just watch me for 5 minutes change everything to have a underline at the beginning. So self, because what I want to do in the streams is to show the logic and the thought process that I have in solving and working these things out. So we don't need this, and if the column, yeah, so the next state is going to be this. At the end of everything, it's going to be this with the new IDX. No, we don't want the new IDX. Oh, how do I? Okay, so let me see. Yeah, because okay, well, this will make it so that it goes to the next question. Okay, so if so, but I want it to stay on the same question for a long time, right? Yeah, so row in self-action class, yeah, because it's then we'll reset and then we'll just pick a new. Yeah, I can just do that. Yeah. At the beginning, at every step, it just takes. Every reset is a new question. Well, not truncated. Yeah, so it just plays the game. Yeah, okay. Yeah, it makes sense in my head. It cleaned up in my head. And so each step we have the IDX being 0. I don't care about that. Anyway, if column is in action class, we have the self dot column is equal to self. Oh no, it's going to be the action. It's going to be an action, right? So it should be an action with wait, so the core is an action with action. Yeah, how do I do it in Blackjack? Actually, the action is action lower. Oh, because I returned the index of the thing here, so it's the index. Yeah, so it returns an action. So no, I don't care about this here in my implementation. I care only about the action IDX because it doesn't carry any information. Blackjack carries information for the hit stand, so I can parse it. This is just pick the correct row effectively. So this is just the action. L if self dot row equals with action, and if the action in self action class, if action is bigger or equal to 10, it's very negative. Else okay, let's have it calculate the reward here. Self reward. So this has a reward of 0 because you're picking effectively. So we can make it self dot reward, not self, to 0, yank and paste here. Yeah, so the reward is going to be self calc reward given the action, and this calculate reward will should look wait, it's gone, so let me go. Yeah, should calculate this. It should calculate this and then this and then the value and compare that to the actual truth. So we need to know the actual truth, and we have the few shots and we have the questions more correctly. So to calculate the reward, we're going to take the self dot questions the self.questions is how did I, oh okay, let me go again here, and then I can do poetry run, and then I can do, oh come on, from, come on, yeah, from dataset import dataset, and then we can set the dataset to be the ARCAGI dataset. Okay, so now let's see, we have it set as question equals with, so we have the dataset, the train, so question is dataset train question, so question is just this, yeah, okay, so question is actually the first one, just to see, and it's an input and an output. Okay, so you have the input and the output. It will be so 0 also, and then calc action here. So the questions is 0. Oh yeah, it's the exact solution 0. Okay. So this is, we have the questions. What we want to do is that the solution is equal to self.questions equal to self solutions. Yeah. Why am my brain froze? So the input. So we want this, but output. Yeah. Okay. So 0, 0, 0 question, 0, 0 output. 0, because this 0, then we have. So we have this, and so we want question 0, 0 output, and it should return perfect 0 output. So this is the solution for the question that we're trying for, and so now it's just a for loop for call in len solution 0. Is it call 0? Okay, for I, for j in len wait, so we have 3 1 2 3, and then we have, wait, for len solution is this, so for len solution, yeah, for len solution 0, because it's always a square grid, but we can also be fancy, it doesn't really matter, and just go with this for I in len solution, for j in len solution I. We have the if no, wait, so here we have because the, how is the solution guessed? I don't know. I can guess it from the output, but at the same time, wait 1 second, what I want to, I could give the description, the size and the description. You have like the yeah, okay, the output, the size, the output is, and then we can just do, this is the step. Okay, so let me just steal this and add it here, wait, here, and start working on this, and then we can just change it down the line. So the size of the output, so we have the questions and we have the output, and the output is You can just say len, so the length should be yeah, len, wait, what am I, so I want the parentheses here and I want to be len of this, output, yeah, comma, open this, paste again. Okay, so output, this gives me the that, and then output by 0. So this is the size of the output. It's 3 by 3, 10 by 10. Although if it's square, is it always square? Let me check. If it's always square, then like we don't really need to, we only need one dimension, right? Not the leaderboard, I don't care about the leaderboard now. Technical guide, square grid. Visual is a grid of colors. Yeah, I saved example. Yeah, you don't care. Description. Yeah. Where is the? It's a 2 by 2 grid. Yeah, I don't care. Yeah, but is it square or not? I mean, I don't know. Let's make it so if we can have it be a parallelogram also. So, but we're going to assume that's a parallelogram, right? So it's going to be by the, all of them are going to be equal. So it's up for a parallelogram also for J. So we check that. Okay, so we need to build our own empty grid of solutions compared to. So we need our own. So the output beams is equal to so output is the yeah. So what we're going to do, I'm sorry, I'm a bit stuck mentally. It's been 2 hours of non-stop thinking. So we need to create our own grid of zeros. So we're going to use output grid is going to be pi.zeros shape is equal to the length. Okay. So wait, what am I doing? Yeah, okay, so let's copy this. Let's len this, len this, comma len. Oh, the thing I don't like about Helix, right? When I delete something, it just puts it into the buffer, so it gets copy paste, so I cannot yank, delete, and yank again. I need to do everything in like yank, paste as many times as I need, and then pretend like then I have to go back. But you know, it's still, I feel I've gotten more comfortable with it than with Vim or new Vim, to be honest. So this is the zeros. We create a grid and we need to compare, so we go to axiom column. Yeah, so so this is self output grid like this, and so now here we have the, oh no, we don't have it. We might want to pass it out to the, for the evaluation, for the eval by the people working on it on ARC-AGI for the Kaggle stuff. We just output a grid. This is a solution. So I can just do it like so. Yep. Because we're going for the parallelogram. So else we have that the self. Okay, so if the action is valid, we're going to go to dot output grid, and then we're going to go to the self dot column and the self dot row, and we're going to say that that is equal to the action. So we're going to make it red, for example, and it becomes red, and so we have the output grid being created slowly, and yeah, I mean, okay, this has nothing to do with the step that we're working now, but like the initializations, this seems too much to me right now, because if we're resetting after each one of these episodes, we're doing it for like 1,000, we're shuffling blah blah blah, right? But I mean, I'm not going to do it for like 1,000. I'm going to make it in total you want millions of episodes of training in reinforcement learning, unless you do the blackjack thing that I did and just does it in one call of the learning function. So this is completely useless for. Okay, so we have the output grid in solution. If we're going to return reward, and so this is going to be an int, because we're going to give if self dot output grid ij is equal to the solution ij. So if the pixel at the output grid is that, we're going to I forgot the column, reward plus equal 1. So the reward should also be 0 here, equals to 0 for I in length solution. So yeah, if it's wrong, wait, if this is 0, this is also correct. We don't want that. If solution say is not equal to 0, then, because otherwise it gets +1 for like just not doing anything. So at the beginning, I mean, yeah, no, it should be 0, and then it gains points for any correct guess it does. And if output else, I mean, this should be more on the top, because then I can play with the reward structure better. So if it is not else, yeah, otherwise it's going to remain 0. We don't care about that. Else, if it is not equal to, if it's wrong, if it's non-zero wrong, or should it be we want to, if they're the same, I mean, yeah, no, the previous way was better, so this is better, and we do it again here. It does not equal to 0 again. So if the solution output grid is equal to the solution, if the output grid is equal to the solution at a pixel, and if the solution is not 0, so we're not here in the zeros, we want to give the agent a good job. And if it has messed up the color at that point, if it has added a color which is wrong, we're going to give word minus equal to 0.5, because we don't want to punish as much. If it gets the correct thing, that's very good. Okay, and maybe we should do something about the black spots, the empty spots. If we go, let's do training set video. So we have that, we've seen that. So because you have here, this fills the entire space, right? But that means that it's never going to trigger anything, because it will add this, it will not get it, it will get a reward for adding this, then we'll move on. But in this situation, if it goes and fills like the correct pattern, let's find an easy one that I don't have to think about. So yeah, it just has to fill everything. So if it goes to 20 by 20, and it goes, for example, it fills the correct one to be here, and then it fills the correct one to be here. I want this to be punished a bit, but I don't want it to be punished a lot, right? And so it should be able to, at the same time, it can go back and play again the move with the 0, right? Because it has the ability to go to 1. Do I want that? I feel like I should be able to do that. It should be able to make a mistake and then go back and fix it if it realizes it made a mistake. I don't know. It feels more intuitive, to be honest. I might remove it to make the color space a bit smaller also at the same time. But yeah, I think this is a good reward. And if solution is not, if the solution is, it should be empty. Because if these are the same colors, this would be like a huge reward boost, right? And then adding a color would not do anything to it. But if it is the wrong color, it should be this. And if it should be the wrong color in general, I don't think I need that, to be honest. Like if it paints something that shouldn't be painted, it shouldn't be able to get a reward from that, or say 0. It should be punished, like, oh, you can't fill this with any color. It's wrong, effectively. So I might do it with a different way. If solution else, not if else. If it should be a 0, let's make it 0.5. Let's make it a bit more negative. Like it's better to guess the correct color than to guess it's better to guess a wrong color at the correct spot than to guess any color at an incorrect spot. It effectively compounds, you can say. Like this would be worth 0.5, and this is 0.4, and added with this it goes to minus 0.3, because it doesn't matter any color, whatever color, it's the wrong color, effectively. Yeah, okay, but I want to punish it for not trying to think about the thing, because this here, it should learn that this is the correct shape to have. First it will make the shape and then we'll try to fill it up, theoretically, right? This is a good like approximation of how I want it to behave. Oh, wait, yeah. So it resets, it goes to 0 horizon. Yeah, okay. I think I will end it here. I'm at a very good spot. I feel like I'm pretty happy with where I'm at right now. Oh yeah, the return here. It should be let me just do the new thing, because okay, so we have the new state should literally just be the exact same thing, but with the so the description, the size of the output is full stop here. So far you have picked. Okay, so yeah, I need to define it, probably dimensions of the output. I mean, we have the output at the reset, right? So yeah, okay, 5-minute adventure. So if the row, if column bigger, I mean, yeah, it's once again, this is the row or the column, that the first one or the second one, because I don't remember. Anyway, if the self.column is bigger or equal to the len, I mean, I'm using this all the time, so let's just do row size self. Okay, and put it here, delete this, and then self.call size is equal to yank, paste, and this. Okay, so the output grid is of shape self row size self.call size, and that means I can probably fit everything here. Yeah, no, wait, I'm confusing myself. Okay, and this should be here. Yeah, okay, so the output is grid is this, and so is the self.column size, and if self.row is, why do I have it self here? Why is this let me remove that. I don't think I need that at all, to be honest, because we're not outputting that, because we're affecting the grid now. Self dot, no, we don't want equal to, we want, wait, we go from 0 to 10, so if the length is 12, yeah, okay, so equal to, yeah, self dot row size. We also want a very negative signal for the agent in that situation. We want to teach the agent to be inside the boundary. So if the boundary is 20, we want, if the box is 20 by 20, we don't want the agent to select column 21. It doesn't make sense. It doesn't like mean anything. So we want to learn to teach the agent to respect the output grid, which will be given to it again. So we have an else here. Wait, we have an else here, and after each step, taking out so far the far your solution is, and it should be the self.output grid. So it only sees its own solution. Select, okay, you are currently selecting the color class. So it picks and chooses and says, okay, this is the, yeah, this is the output grid, so this entire thing should be okay. So what is updated? You have the examples, the input for the question, and then the size of the input, which is the column size. I can just replace that now. Self.rows, is it the I don't know, honestly. I need to figure it out. Like, okay, let me use the magic of dims in NumPy. Culver's row, which one is it? So the number of dims, yeah, the B is number of dims is 1 because it picks up the fact that it's one dimensional. The size is 3. So if we have this does not have row vectors. Yeah, it has arrays. But what does it mean? Damn, okay. Okay, so sure. So this is buddy in the chat can help me out. Yeah, so it is, yeah, okay, yeah. But is it row first or size? I might resort to asking ChatGPT. Wait, okay, so we're vibe coding. People are annoyed that I might use ChatGPT for this. Not in most people, but like some people. Like 1, 2, 3, 2, 3, 4, 3, 4, 5, right? Yeah, okay. Okay, so it's a row. I'll trust ChatGPT completely and not question it. So it's the row size, so it was correct to say that. Okay, let's make sure. Yeah, the call size is this one. Perfect. Yeah. Okay. So we want the row size and the call size. Yeah, the row by column. So it should be first you pick the row and then the column. Yeah, okay. Leave row, column, color. Yep, okay. Oh, you're parting exam. Yes, yeah. The title of the output is row by column. Okay, and if the row size, color size, yeah. So it should be in for I in length, in self, row size, for j in self dot call size, and because these are just numbers, range, do this and just do this. Okay, we can close you. Close these things. Yeah, okay. I mean, what's a good background? Another, oh, that's not a good background. This is a good background. So it, based on the column, based on the row, range, column, it goes to the row and column and picks this. Yeah, okay, I think we're done. I don't know what I'm missing. So now it needs to start being going to finishing this and fixing things out here, which I might do at a later point, but now I've been streaming for 2.5 hours, 2 hours and 1/4. So I might stop here, just take a break, eat something. Yeah, so thank you very much. Very nice to see, have a conversation with somebody. It was really nice. So thank you for being here and interacting and joining in. Yeah, and hopefully I'll see you soon. This video will also go on YouTube. You can find it on my channel. I'll maybe add a link to it. I'll post it maybe to the ARC-AGI channel. But yeah, thank you for joining. See you next time, whenever that is. Goodbye.